Let's look at multiplying and dividing fractions. Now, when we had talked about multiplication with whole numbers, we talked about first that multiplication could be thought of as repeated addition. So here, 2 times 3 can mean I need 2 of the 3's. And 2 of the 3's, when I add them, give me 6. We can kind of think of the same way as far as multiplying fractions. So here, if I wanted to find what 1/3 times 1/6 is, again, the 1/3 tells me how much of the second quantity, which is 6, that I want. So we often say 1/3 of 6 to mean multiplication. So here I've got 6 dots, right? And if I circle 1/3 of them, then I have that 1/3 of 6, or multiplied by 6, is 2 dots. So again, when we're taking a whole number times a fraction, we can think of this as repeated addition like we did earlier when we were discussing multiplication with whole numbers. So the figure that I'm going to show you indicates the number of times the fraction is added to itself. So 3 times 2/5 would be 3 of the 3 2/5 put together. So it would look kind of like this. So I have this first bar that has 2 of 5 shaded, and another bar that has 2 of 5 shaded, and another bar that has 2 of 5 shaded. So by repeatedly adding these 2/5, I have 2/5 here, plus 2/5 here, plus 2/5 here, and I know when I add these now, I add the numerator 6 and keep the same denominator. I can also see that because here I have a whole bar that's been filled up with all these pieces, and then I have a 6th left over. A 5th left over. So we can also see that this is equivalent to the mixed number 1 1/5. So an illustration of a fraction times a whole number. So here we have 1/3 times 4th, which means 1/3 of 4. So we can use this by taking 4 bars that represent a whole. So right here, that's what we have. 4 bars where all parts are shaded, or where the whole bar is shaded. And then I want to divide this so I can find where 1/3 of all the shaded region is. And 1/3 would be that part right there. So what we can write is that 1/3 times 4 is this third plus this third plus this third plus this third, or 4/3, which we can look and see that these are 4 pieces, and now by having divided these lines, each of these pieces are thirds of the bar. So in this picture, we're going to use fraction bars to illustrate the multiplication. And what I've done is I've taken 4 whole bars, and then I've taken 2 whole bars, just for comparison, that were divided into 3 pieces. So I can think of putting 4 whole bars next to each other, and then I want to find out, well, what's a third of this? What's a third of the region that's shaded? Well, it's this whole bar and this part of another, and so I can see that it's a whole bar and then 1/3 of the second bar. So we have 1/3 of 4 is 1 and 1/3. We can also say that 1/3 of 4 is 1, 2, 3, 4 thirds. Either way you want to write that, you can. Now, multiplying a fraction times a fraction, we can illustrate with both a fraction bar model and a rectangular model. The rectangular model somewhat like what we used with whole numbers. So let's think of what this product 1/3 times 1/5 means. So we're looking at 1/3 of 1/5. So what I can do is I can first, and I don't think I've already done this, no. I'm going to divide this, and they're not going to be pretty because you know how well I can draw by now. Okay, so I've taken this rectangle and I've divided it into 5 supposedly equal portions. So if I shade 1/5 of it, that's what I have right here. But I want to find out what's a third of this shaded region. So if I go ahead and just to make it easier and divide this horizontally, then this is the part that's shaded, but I only want a third of it, so I only need one of these. Well, how many pieces are there altogether now that I've divided it up? Well, there's 15 pieces. 5 times 3. And then when I shaded this region, I only shaded 1 out of the 15 regions. So I can say that 1/3 times 1/5 is 1/15. You may notice a quicker way to do this because you've had more experience, but looking at these examples will help us to generalize into a rule that we can use. This time I'm going to do the same problem, but I'm going to use a fraction bar model. So here's a fraction bar model of fifths, okay, and I only want one of these fifths is what I'm talking about shaded. So now I've shaded 1/5, but I want to find out what is a third of 1/5. So if I divide this into 3 in a similar way that we did when we were finding common denominators, I only want 1 out of the 3 pieces. So again, I have 1 as the area I need, or as the portion I need. And now each of these are in 15ths. So it's 1/15. So I'm going to get this same way, the same answer, even though I use a different way to do it. The model you choose to use when you're in a classroom, you'll choose to use based on how well your students receive certain models and their ability to connect those models to what's going on. So let's do another illustration of multiplying a fraction times a fraction, keeping in mind that 2/3 times 4/5 means I want to find 2/3 of 4/5. So we're going to draw a rectangular model again. So I'm going to first illustrate the 4/5 by dividing this into 5 parts, shading 4 of those. So I've got 4/5 shaded. And now I want to find what's 2/3 of that. So here I'm going to split these horizontally into thirds. So if I take 2/3 of this, here's 1/3 of the shaded region, here's another third of the shaded region. So what's shaded? 1, 2, 3, 4, 5, 6, 7, 8. And what kind of pieces do I have when I've divided this region up? Well, they're 15, so that's 8 out of 15. Now we can look at this with a fraction bar model. Okay, now I'm going to start out with this fifths model bar, so we're looking at 4 of those. Let me see if I can change this to a lighter color. So this will represent 4/5. Now, I'm wanting to find 2/3 of 4/5. So what I can think of it like it is this. If I divide these into thirds, I want to shade every 2 out of 3. So here's 3, so I shade this one and this one. Here's 3, shade this one and this one. Here's 3, shade this one and this one. Here's 3, shade this one and this one. So how many parts do I have shaded? Well, I have 1, 2, 3, 4, 5, 6, 7, 8. And since I've taken this bar and divided each of 5 pieces into 3 smaller pieces, I now have 15ths. So I have that 2/3 of, or multiplied by 4/5, gives me 8 out of the 15 pieces that were there. So the rule for computing the product of two fractions is suggested by what we've just done. We've kind of written it as we went along because it's natural for us to do. Okay, so then each model, we needed to determine the total number of equal parts we had. And in this case, we could find that number just by taking the number of parts in the first denominator times the number of parts in the second denominator. And the product would be the darkly shaded parts when we went back and shaded those. So basically what we can say is we can find the product of two fractions by multiplying numerator by numerator and denominator by denominator. So this is the rule, and this is the rule you're used to seeing. If I take a fraction a over b and multiply it by c over d, I just multiply my numerators, multiply my denominators, and that gives me my new fraction. Now always, once you get to this part, if your fraction will reduce, once you get to a final answer, reduce if you can, but if you can't, don't worry about it. So now let's look at division. Okay, so we can look at this the same way we looked at division of whole numbers. We looked at division as repeated subtraction. So we can do that here too. We also looked at division as trying to find a missing dimension in a rectangular model. So, like we did before, one of the meanings of division of whole numbers is the subtractive or measurement concept. So, for example, if we wanted to explain the problem 15 divided by 3, we often say, how many times can you take 3 away from 15? So if we looked at this problem where we have 3/5 divided by 1/10 in the same way, we're going to be asking how many times can we take 1/10 from 3/5. Okay, so here again what we just said. So what I've done is I have illustrated 3/5. So let me do this in a different color so it kind of stands out. So if I shade 3/5 of this, and then to compare it to the size that I want to see how many I can pull away, I have tenths in the bottom fraction bar. So I can ask, how many times can I subtract a tenth from 3/5? Well, here's a tenth, here's another tenth, here's another tenth, here's another tenth, here's another tenth, and here's another tenth. So how many can I take out? 1, 2, 3, 4, 5, 6. So a tenth can be taken out 6 times. So when we look at our problem, the 3/5 divided by 1/10, how many times did we take that tenth out? 6. Now obviously here we're not just multiplying the numerators and multiplying the denominators, because that's not giving us the right answer. So let's look at this. This interpretation of division of fraction continues to hold even when the quotient is not a whole number. Okay, so sometimes when you do your division, you have a remainder. We've seen that happen before with whole numbers. So the next slide is designed to kind of show you what you do in that case. So sometimes when we divide whole numbers, we end up with remainders. And when we have those remainders, we write the remainder as what part of the fraction is it that's left over. So here I'm taking 5/6 and I'm dividing it by 1/3. So here's my 5/6 bar up here. So 5 out of the 6 are shaded. And what I want to see is how many times can I take out 1/3 out of here. Well, I can pull out 1/3 here, and then it would be another 1/3 here. But then I have this is my remainder. Okay, now what I was dividing by was 1/3. Okay, so what I end up with is 2 from this part, and then the remainder part you can see is 1/2. So what's shaded here, the top, and what's shaded here, this is 1/2. So it turns out that 5/6 divided by 1/3, you can take it out twice, and then you're left with 1/2 left over. So one of the early methods of dividing one fraction by another fraction was to get a common denominator, which we do when we're adding and subtracting fractions. And when this is done, then you can find the quotient just by not paying any attention to the denominators. You can just divide the numerators. Okay, so if the original problem was 2/5 divided by 3/4, we can write 2/5 as 8/20, and 3/4 can be written as 15/20. So now that they have the same denominator, I can just ignore that part of the problem, and basically, because I'm going to have 20 divided by 20 is 1, I'm not going to change anything, right? So I can just ignore the denominators and look at the top part, 8 divided by 15, and write that as a fraction. Now, when you're taught to divide, you're usually taught to take one fraction and then multiply it by the inversion of the second fraction and do your multiplication. So if I'm going to take 1/2 divided by 1/3, I change that to 1/2 times, turn this to 3/1. It's called reciprocating. So this problem becomes this problem, and now we can just use our multiplication. I multiply 1 times 3 to get 3, 2 times 1 to get 2, and 3/2 can be written as 1.5. So looking at the invert and multiply rule for finding the quotient of two fractions, it looks something like this. So I have these two fractions, a over b and c over d, and I have to make sure that c over d is not 0. So if I take a over b divided by c over d, then what I can do is I leave the first fraction the same, change the operation of multiplication, and invert the second fraction. And then this is the problem that I work. A times d is equal to AD, b times c is equal to BC, so that is my quotient right here, what I get when I divide. So the division is just defined by what it means to multiply.